This is Team 31's proposal for our client, Team 41.
The project that we were assigned by Team 41 for a machine consisted of the machine having a dry erase marker and driving forward towards a whiteboard. And once it reached a whiteboard or a wall, the dry erase marker would go in circles until a button was pressed for it to stop. And through that, we went through our design process and built a prototype.
All right, so this slide just outlines some questions that we had for the client group. So first, we wanted to know if we had to do anything with the cap during the machine's progress throughout its task. And then our second question, we wanted to know if it had to turn or steer when it was approaching the board. And the answers to these were no, we did not have to cap the marker, and no, it does not have to steer.
Some of the specifications and customer needs that we looked into were how the machine moved toward the whiteboard and the circles that were made by the machine. We tried to quantify them by when the machine would stop before the whiteboard, and also how many circles that were being made from the dry erase marker on the machine. And we put a technical requirement of that when the tip of the marker touches the whiteboard, the machine should stop, which was also our target value. And the machine should also make at least 2 circles, which we input on to make at least 3 circles for our final prototype.
Here we see the system, FBD, and a flowchart. The system consisted of various hardware components, motors and sensors, and software components with the Python control program. The Raspberry Pi provided the interface between hardware and software. The ultrasonic sensor detected proximity to the wall, which it fed to the Pi. The Pi then determined appropriate settings for the drive motor and drawing motor. During this time, the Pi monitored the touch sensor and shut down the program when the touch sensor was activated. The flowchart seen here is detailed and complex, but the program really consists of 2 simple loops, the main loop and the drive loop. The main loop determines distance from the wall, and based on that, distance either activates the drive loop or activates the drawing motor. When the drive loop is activated, the program continues to get distance data, and from that data sets the drive speed. If the wall is far, the device goes quickly, and when the device reaches an adjustable distance from the wall, it slows down to prepare for contact. Once it reaches the wall, it goes back to the main loop, which activates the drawing motor and also applies a small amount of torque to the drive wheels to ensure marker contact.
Okay, so these are some alternatives that we had to for the first design. The first design had 2 motors in the back, and each wheel had an axle. By having 2 motors in the back, there would be more structural stability and power. However, the chassis was then later changed to only have 1 motor in the back, as can be seen in the final prototype. This is to ensure that the 2 wheels turn at the exact same rate, and this would help reduce some of the turning problems if the wheels were turning at different rates. Furthermore, the first design used this large motor for the arm system. However, in the final prototype, a small motor was used so that the motor could be placed parallel to the length of the chassis, which would help with structural stability. Finally, the first version of the code had the motor stop when the markers hit the whiteboard. However, in the final design, this is changed to where the motors slowly move forward to keep the marker pressed against the wall.
All right, so these videos show a demonstration. If you look at the middle video, it demonstrates the design stopping at the press of the button as set out by the client team. And then the video on the far right shows the actual robot approach the board and draw a circle. It does take a second for the full circle to come in, but as you can see there, it does get a full circle.
We hope this satisfies your design intent, and thank you for watching.